pursuing BE in Electronics and Communication Engineering in SVCE Bangalore. I am from 3rd semester A section. Today my subject is Electronic Principles and Circuits and the subject code is BEC 303. And today my topic is other types of bias. Discuss the circuit diagram of other types of bias with relevant equations. First one, emitter feedback bias. Second one, collector feedback bias. And the last one, collector and emitter feedback bias. So let us see about the emitter feedback bias. To stabilize the Q point, first attempt is done, that is emitter feedback bias, as shown in figure A. This is the figure of emitter feedback bias. An emitter resistor has been added to the circuit. The basic idea is if IC increases, V increases. It causes VB to increase. If more VB means less voltage across RB. This results in less IB, which opposes the original increase in IC. It is called feedback because the change in emitter voltage is being fed back to the base circuit. The movement of the Q point is still too large for most of the applications that have to be mass produced. The equations to analyze the emitter feedback bias are IE is equals to VCC minus VBE divided by RE plus RB bar beta DC. This is the equation 1. VE is equals to IE into RE. Equation 2. VB is equals to VE plus 0.7. Equation 3. And the last one, VC is equals to VCC minus IC into RC. Fourth equation. The intent of emitter feedback bias is to swamp out the variations in beta DC. That is, RE should be much greater than RP bar beta DC. If this condition is satisfied, equation 1 will be insensitive to change in beta DC. This is all about the emitter feedback bias. Let us see about the collector feedback bias. It is called as self-bias, another attempt to stabilize the Q point. The basic idea is to feed back a voltage to the base to neutralize the collector current IC. If IC increases, VC decreases, VB decreases. This causes to decrease in IB, which opposes the original increase in IC. The equations for analyzing collector feedback bias are IE is equals to VCC minus VBE divided by RC plus RB bar beta DC. Equation 1. VB is equals to 0.7 volts. Equation 2. VC is equals to VCC minus IC into RC. Equation 3. The Q point is usually set near the middle of the load line by using a base resistance. The equation obtained is RB is equals to beta DC divided by RC. Collector feedback is more effective than emitter feedback bias in stabilizing the Q point. This is all about the collector feedback bias. So let us move on to the last one, collector and emitter feedback bias. As collector feedback and emitter feedback circuits fall short because this is not enough negative feedback to do the job. To improve the stability of Q point, both collector and emitter feedback is combined as shown in figure C. Here is the figure of collector and emitter feedback bias. This circuit helps but still falls short of the performance needed for mass production. The equations are IE is equals to VCC minus VBE divided by RC plus RE plus beta DC. Equation 1. VE is equals to IE into RE. Equation 2. VB is equals to VE plus 0.7 volts. Equation 3. And the last equation, VC is equals to VCC minus IC into RE. Fourth equation. This is all about the collector and emitter feedback bias.